All right, today we're going to be doing a quick review for our test just to make sure that you guys have all the knowledge you need to be successful and get a good high score. All right, so the first thing we want to look at are these states of matter. And in investigating these and glancing over what we have here, a couple of things I want to point out that's going to be on your test and I want you to be aware of. First thing, if you look at the solid here, you'll notice that between these particles that make up that solid, these are very close together. So there's like little space here. Whereas if you move into the gas or the plasma, you're going to have much more space between those particles. And you want to just also know that if you look at this arrow is for energy. And so down here at the solid, you're going to have low energy. And down here with these last two, the gas and the plasma, you're going to have high energy. And one thing we like to say is that these, the plasma particles, the atoms that make up the plasma, the particles, the molecules, those become charged. And so the basic difference between a gas and a plasma is you're going to have higher energy because those particles are going to be charged, and that means positive and negative. Now at this time, right now, we haven't really jumped into that, so I wouldn't worry too much about what that actually means. Just know that that's something that you're going to see. Solids are going to have a definite shape, definite volume, whereas if you move down to the gases and the plasmas, there's an indefinite shape, indefinite volume. Buoyancy. When we talk about this, one thing I want to say is that if you look, you'll see that this is kind of floating in that water. Okay, so this all has to do with density. Okay, so the density of water. So the density of water is going to be 1 gram per milliliter. If something has a density that is less than 1 gram per milliliter, it is going to sink in the water. Okay, so that would be down here, greater than 1 gram per milliliter. It's going to sink. And again, we go ahead and correct this too. And there we go. Greater than 1 gram per milliliter is going to sink because it's heavier than water per volume. If it's less than 1 gram per milliliter, it's going to float. Okay, so again, up here, that would be the less than 1 gram per milliliter. Okay, it's going to be floating in that water. And so what you just need to understand is if something has a higher density than water, it's going to fall to the ground. It's going to fall to the bottom of the cup. If something has a density that's less than water, it's going to float. Now, if the density is exactly the same, it's probably going to just stop right here and just kind of like, float up and down and move around with the water molecules as they're kind of doing their own thing, moving around. But again, buoyancy is entirely 100% dependent upon the density of a substance. And speaking of density, here we have some physical properties. Now, what these all have in common is that they can easily be observed and measured. So you don't actually have to change the matter in order to identify these. You can just look at the matter, you can examine it, you can just see it with your own eyes. Okay, we talked about density, mass, and volume, but just so you know, density is equivalent to mass divided by volume, and that mass should always be in grams, and that volume should always be in milliliters. We could also do it differently, but for right now, that's what I want you to keep in mind. Okay, we could change those measurements if we wanted to, but let's keep them right there for right now. Color, length, you guys know that. Width, same thing. Height, you can know that. Malleability is going to be the ability to hammer it. So you can actually take a hammer, you can strike that material, and you can cause it to become flat. And the most malleable element is gold. So gold is the most malleable. If you hit that with a hammer repeatedly, you're going to flatten that out into a flat sheet 1 cubic inch of gold could cover an entire football field. I know that sounds incredible, but it's the truth. Of course, you would have to spend a lot of time hammering that gold in order for that to happen. But there it is. All right, and then chemical properties. These can only be seen when matter changes into other matter. So what causes that will be a chemical reaction. A chemical reaction is going to cause a chemical change. So a chemical reaction will cause a chemical change. And once again, just understand that a chemical change is going to result in matter that is completely new, that is not the same, does not have the same identity. A couple of these are combustibility and flammability. This is the ability to burn. Reactivity means the ability to have that chemical reaction. Not everything is reactive. Even water is reactive with sodium. Okay. pH level, that's basically going to tell you whether something's an acid or a base. Stuff like vinegar and your stomach acid, hydrochloric acid, those are acids. Bases are things like calcium carbonate and baking soda. Some of your soaps and cleaners are actually basic. Drain cleaner, that's sodium hydroxide, that's also a base. And then toxicity means that something's poisonous. Now, the thing about these chemical properties is that you have to do something to test them. You cannot just look with your eyes and see. So you have to go through a test of some kind or some kind of a chemical reaction in order to see these properties that are present in that substance. You just cannot look at it and know that you have it. And these are all chemical changes. These are great examples of chemical changes. But again, the one thing these all have in common is where you have matter becomes a new substance. So matter is becoming a new substance, something else entirely new. Something new is, I don't want to use the word created. I'll put parentheses or quotation marks. Something new is formed. It's not created, is formed. But for you right now, you can use the word created. It's fine. Later on, you'll see why that might not be the exact case. But just understand that you'll have something new. Great examples: rusting iron, cooking food, especially eggs. That's a big one that trips people up often. If you cook anything, if you burn anything, and if you have that acid-base reaction, like if you baking soda and vinegar, you'll see bubbles. So a couple of things that are indicators of that: you'll have the bubbles, you'll have a solid precipitate that's formed, you'll see some kind of a temperature change, the formation of an odor, any kind of an energy release or energy where it absorbs energy from the environment in the form of a endothermic reaction. But there are certain things that you'll see with your eyes, that you'll observe when this is happening, to know that a chemical change is taking place. But the big idea here, the one takeaway, the one thing that really matters is that there is a new substance that is created when a chemical change occurs. Here's a great example of a chemical change. We see here that this is going to be where oxygen is being used by the fire, and it releases carbon dioxide and water vapor. And then when we look and what we have left over, we have all those ashes, which is mostly carbon that's left behind as this fire burns. So again, if you look here and you look here, you can see that they are not the same thing. These are two different things. So you know that this, any kind of burning, whenever you burn anything, so any kind of burning is always going to be a chemical change. And that chemical change is going to rely upon the chemical property of combustibility. So combustibility is the ability of this to break down and combust into this product that you see left over. The products of the chemical reaction are the carbon dioxide, the water vapor, and the ash, because that's what's left over when you go through that reaction. Here we're seeing, this is the formation of a solid precipitate. This is that dangerous reaction that I showed you, but you see you have two transparent liquids here. And when they come together, it forms a solid that starts at the top and begins to fall down, and when you're left at the very bottom, you have this yellow powder with this lead nitrate reaction. But again, a couple of things you see here that are indicators of a chemical change. First of all, one of those is color change. When you see a color change occur, and that's kind of confusing because a color change is a physical change, but if you see it happen between two chemicals, that can kind of tell you that there's also a chemical reaction taking place. So don't think that things are always either a chemical change or a physical change. Sometimes you can have them happen at the same time, and this is one of those examples. But you also see in this reaction a solid precipitate that is formed. And when that occurs, it begins to fall at the bottom. So these are indicators of a chemical reaction or indicators of a chemical change. Physical changes, going back on this, is any change in the physical properties. So like, let's say you have a piece of paper and you take some scissors and you were to cut it in half, and now you have two halves of the paper. Now this is still paper. You had paper when you started, you had paper when you ended. It's still the same, it just changed in size. And because size is one of those physical properties, and all you did was change a physical property, this is therefore a physical change. It does not change the substance, it's still the same substance, but any cutting, crushing, coloring, smashing, breaking, those are all great examples of physical changes. So here are some more examples of that. You can see that, mixing things together like Kool-Aid or sugar and water. If you shred paper, chop wood, dissolve things, crush a can, melt an ice cube. Oh, by the way, let me go ahead and just say that right now. All state changes are physical changes. So whether it's melting, freezing, vaporizing, condensing, sublimating, deposition, all of those things, those are just state changes. Those are just physical changes. State is a physical property of matter. Okay, so if you change that physical property, it's just a physical change. Okay, so again, all state changes are physical changes. And a couple we left out here. We had that.
Mr. Garner?
Yes. Yes.
Can you please tell me if AJ allowed in the homeroom?
No, he is not.
Okay, thank you.
Thank you. So deposition and sublimation. Those are also going to be state changes. And again, those are physical changes. All right, so looking at that state change diagram, you need to be able to cite an example. Give me an example of every one of those. If we go back, every one of those state changes, give me an example of condensation. Give me an example of vaporization. Be able to tell me. And if you do not know, then I need you to look that up in your notes to make sure you are ready for that. Okay, so you need to have an example to cite from each of those state changes, all the ones that I just touched on. So when you look at these, the structure of matter, looking at the particles and how they kind of come together, let's just know a couple of things here. First of all, solid, low space, right? So you don't have space between the particles, and because of that, you typically have lower volume. That volume is definite. That shape is definite. These are tightly packed together, and these are moving very slowly. Okay. When you get to a liquid, liquids, they lose that definite shape, but they still have a definite volume. And they begin to kind of spread out a little bit. They have a little bit of faster movement. Not the fastest, but they speed up a little bit, and they're slipping around one another. They lose that shape. They don't maintain a definite shape. Now, when you get down to gases, you have an indefinite shape and volume. You have a lot of space between those particles, and you have fast movement. Now remember that movement, we have a name for that. We call that kinetic energy, or Ke. So when we have thermal energy, that means temperature, we're going to see that kinetic energy pick up and that speed pick up, so it gets faster. Here are some great examples of physical changes versus chemical changes. And then again, we go back to this these states of matter. Now, remember that if you see a state change diagram, and I'm not going to tell you it's going to be on there, but be prepared for it. Remember that this is a solid. Then we have that state change from the, so we have a solid, which is that diagonal line. Then this horizontal line is going to be a state change going from solid to liquid, so melting. If you go the other way, that is freezing. Then another diagonal line, that's a liquid, right? So down here you have your definite shape, definite volume. On this liquid, we have an indefinite shape, but definite volume. Then we have the vaporization. And again, if you're moving the other way, you're going to have the condensation, but vaporization. And this line right here, this y-axis is temperature. And then down the bottom, we just have energy we're adding over time. But over here, this last diagonal line would be a gas, indefinite shape, indefinite volume. So just be aware of that, and just understand that the space between the particles in these different states of matter, that will definitely be on there. Okay. Again, these are the indicators here. This is a little bit confusing because these are, in fact, some of these are physical changes, but these things happen when you have, like, let's say you have a flask. You have a chemical inside, and then you do something where you add like maybe a powder to it, and then it forms something else. Okay, you're going to see a couple of these things occur. Usually, I would say most of the time you're going to see at least two of them, but you'll always see one. You'll always see one. Most of the time more than one, but always one. There's no way a chemical reaction can occur without one of these 5 things happening. Okay, and I like to, sometimes, when I talk about temperature, I could really just change this to some kind of an energy change, because you guys know right now, after having talked about this, that temperature is energy. So there's some kind of an energy change. It might even give off light. It might even glow. So anytime you have two things that mix together and they glow, that is another type of energy change. All right. Understand sublimation deposition example. So this right here, this is CO2 dry ice. So the dry ice is going from being a solid, and it is turning into a gas. It's skipping liquid altogether. And that's frozen CO2. It's very cold. Don't touch it. And then, speaking of something else that's cold, you can also have that water vapor that's in the air around you on a hot day, or on a cold, let's say cold night, right? And it gets so cold that water vapor freezes on your car's windshield and becomes a solid. And that's another example of deposition. So we have sublimation and we have deposition down here. All right, guys, so that's the end of my review. This is not everything. Please look over your notes. Make sure that you're ready. I would love for you to score really high on this, get an excellent grade, do very well. Your parents want to see good grades. I want to see good grades. You want to see good grades. Study. Ask me questions if you don't understand something, you want more clarification on it. Because if you do well, it is a win-win-win. Everyone's happy. Thank you for watching, and make sure you look over your notes.